I wonder if we could get a tiny bit into details, because I think a lot of people know some of these details, at least in lay terms right now, that there's something called the Copenhagen interpretation that
Yeah.
says the probabilistic fields of quantum mechanics collapse when you measure them somehow and turn into a specific measurement. And then there's another interpretation that was considered far out for a long time, but now has many mainstream followers, which is this many worlds hypothesis,
true, yeah.
right? That as quantum states explain all of these different options, that every single one happens, and that the universe is forking all the time. Is David Bohm's interpretation of quantum theory in line with one of these two interpretations, or is it a third one?
Well, David Bohm really has his own unique interpretation. His interpretation is closer to many worlds, right? The traditional interpretation was, the double-slit experiment, where, the conscious observation, when you bring an observer into an experiment, basically the wave function collapses. And this was something that was a huge mystery in terms of quantum physics. Now, Niels Bohr, of course, was the physicist who, I suppose he's regarded as the supremo of the Copenhagen interpretation, which is the two-slit experiment. But the idea that the wave function collapses when it's observed has been one of the greatest mysteries in quantum physics, and still is a huge mystery in quantum physics to this day. But it depends really on how you view it, right? Niels Bohr was not so interested, and the quantum physicists at the time were not so interested in why, because all they were interested in was the statistical information and the data that they could collect to advance at that time the war effort and work on other things. And every physicist, there's a famous kind of expression, was just told to calculate. Don't mind what's going on underneath. Just we've got plenty of information. We don't need to know how we're getting the information, but we have the information, so let's use it. But Bohm eventually, he kind of ignored the double slit. He knew that there was something much deeper going on within the quantum world. And eventually, Bohm's theory arrives at a point where there is a single wave function that is determining everything. It's not many waves, it's a single wave function. And that single wave function encompasses the whole picture. Right? So that's really where Bohm, in kind of simple terms, arrives at. And we've an animation in the longer version of the film that actually explains that in a lot of detail. So we go through the two-slit, we go through the quantum potential, non-locality, but eventually we arrive at this idea where the single wave function, that there is one wave function that is orchestrating everything in the universe. That's really what it is. The many worlds theory is close to that, but off it slightly, but could almost be a sister to that theory in a way, because they are very close. Because once you accept the idea of non-locality and particle entanglement, it's like what's going on here could be mirrored in other places in the universe, I haven't delved deep into the many worlds theory, but because because Bohm gives me a very coherent explanation of how everything is operating in the universe, that not only sits well with me from a non-physicist point of view, because I would never in any sense tell anybody I was a physicist. It was my job as a filmmaker to try and decode what the physicists were saying and somehow make it accessible to people through the film. But to me, he gives me, and I think he gives, and I think is recognized now, certainly in more recent times within the Western physics community, as giving us the most plausible explanation and most coherent explanation for the nature of reality and how reality works, essentially.
Mm. And so what he describes, it's not new or additional math on top of quantum physics. It's a way of interpreting what quantum physics is saying about the universe. Is that right?
That would be correct.
Uh-huh.
He deliberately titled his hidden variables paper. He said that we must always allow for a hidden variable, right? And the hidden variable is something that could well be unreachable by science now or into the future. He left that entirely open. So there was a certain sense that we must have a certain humility in the face of creation, in the face of what's going on there. And of course, this is something that's echoed also in Eastern traditions, you know, that while Eastern traditions have traditionally used mind and wisdom and meditation, you know, Western science uses laboratories and instruments and so on. But ultimately, they both come to the same point. And the same point is, well, what is reality? You know, and I think that Bohm, through his hidden variables paper, gives us a very coherent explanation. It certainly is taking us in a direction, not a final theory by any means, because he never believed there would be. He believed that for every question we ask, we're going to get 1,000 answers. And each of those 1,000 answers is going to raise 1,000,000 new questions. So in other words, there is no end to this. And that's what's beautiful. It's a journey without a destination.
Yeah, even some hardcore, you know, atheist scientists that I've heard and read say the same thing in this humility of knowledge, that we replace wrong theories with less wrong theories. You know, there's never the right one at the end. But a question from the scientific perspective is: are Bohm's theories testable? You know, in the way that we look at science today in terms of making falsifiable hypotheses, or are they more interpretations?
No. They're absolutely testable. And right now at the University of Toronto and indeed at UCL in London, there is work going on specifically to prove the quantum potential. And if the quantum potential is proven, if Bohm's theory is ultimately proven, now the chief scientist there, who actually featured in the documentary, Basil Hiley, he is absolutely 100% confident that they have proven it. But it has to go out, if you like, to the wider physics community for verification. But of course, but there's a lot of skeptics, of course, out there. But the maths and the physics are there to prove it. But this work continues in London, and it's also similar work is continuing in Toronto, and it's all based around Bohm's hidden variables view that embodies the quantum potential, that embodies non-locality, and the idea of quantum entanglement and our interconnectivity. So all of these philosophical ideas come out of it, but at a core scientific level, absolutely, it is testable and is being tested.